Today we proved the sphere surface area formula, which is 4 times pi r squared. To do so, I'll use integral calculus. First, we have to find the area of this shaded band. We can approximate this shaded band to be a cylinder. To find the area of this band, we're going to need to find the circumference of the circle shown above the band and the width of this band. First, we have to find the radius, which is this length shown here. To do so, I'll construct a right triangle as shown here. This right triangle has hypotenuse r. And let this angle be theta. So now we can find out that this side is r cosine theta. So the radius is r cosine theta. After finding the radius, we need to find the circumference. So the circumference is 2 pi times the radius, which is r cosine theta. Now we need to find the width. To find the width, I'll first mark out this angle. Let this green angle be d theta. If this angle is d theta, then in a unit circle, this length shown in green would also be d theta. However, this is not a unit circle. This is a circle with radius r. So instead of this green length being d theta, it will be r times d theta. Now the surface area can be expressed in terms of theta. So the surface area of this sphere is the integral from negative pi over 2 to pi over 2. 2 pi times r cosine theta times r d theta. Since this is a sphere, we only have to calculate the surface area of half of this sphere and then multiply it by 2. So the surface area of the sphere can also be expressed as this shown below. So now let's calculate this. We know that the derivative of sine theta is equal to cosine theta. So this is the same as this shown here. Now let's calculate this. Since sine 0 is 0 and sine pi over 2 is 1, then this is just equal to 4 pi r squared. So we have successfully proven that the surface area of a sphere with radius r is 4 pi r squared.